Hello again, and welcome back to the Watershed Lab. Today we're going to be talking about data zones, and this is kind of cool equipment in terms of things that kind of get biologists happy about the equipment they're using. Kind of more, I'd say, not real modern, but kind of has some capabilities that are hard to duplicate elsewise. So this particular one is called an XO2 to be precise, and the purpose of a data zone is to take your parameter readings, very similar, in fact exact same ones that we talked about in the earlier episode with the multi-parameter probe. So with these we can get temperature, dissolved oxygen, conductivity, and pH. The equipment manufacturers do have other probes that allow you to look at things like chlorophyll A or phycocyanin, different things like that that allow you to also take other readings, and so those, depending upon what you're looking for, are available to put on these, and you can just take off one probe off and put another probe on as you see fit. So if these are mainly doing these the parameters that we talked about with the multi-parameter probe, are dissolved oxygen, pH, temperature, and conductivity, then what's the difference between them? So the main difference is that a data zone allows you to store your data within the instrument itself. So you don't have to be connected with a cord in order to use it. They make different ones. I'll start off with the handheld, which is just basically a glorified multi-parameter probe. This has very similar way of using it and capabilities as multi-parameter probe. So here's our set of probes that this particular one has on it. This one actually has a turbidity meter on it, so we can actually take turbidity readings. It's a pH, a DO, and the conductivity and temperature. So those are the five parameters that we're able to use with this particular setup. So what's the difference between this then and the multi-parameter probe that we looked at before? This particular one, not much. As you can see, there's a cord attached to it. There's a readout that would essentially give us the same readings directly from the data zone that what is happening in real time. The big difference on this particular one is the length of the cord. This is I can't remember, it's 25 foot cord on it. The multi-parameter probe only had about a 5-foot cord on it. So this is you're able to deploy this into a lake environment, for instance, that's like our lake out here is in the summertime especially, it doesn't get much above about 12 feet. So this has enough cord to allow us to get all the way to the bottom. So that would be a way that we could take bottom readings, or maybe trying to look for the thermocline in the middle, or whatever we're trying to kind of discover, will allow us to reach that, which we couldn't do with our shorter multi-parameter probe. So like I say, the handheld version of this is just kind of a glorified multi-parameter probe. It's got a protective casing that it's stored in. There's always water in here. You always want to keep some amount of water just to keep those probes moist. Like on our multi-parameter probe, we always put the pH thing in a pH tube, and when we were traveling from site to site, we always wrapped it up in a wet towel, if you remember right. Kind of the same thing with this. We just want to have a little water in here. You actually don't want the water covering the pH. You just want to be able to keep the whole environment inside this moist. Okay, so this one is a little bit different in that it's not connected to a cord. So this is really where the data zone starts to shine. If we can deploy it without a cord, that means we can deploy it at any depth. As long as we can attach a rope or something to it and lower it down and keep it in place, we can take readings. The other big plus is when you have an autonomous unit like this, so it's, you're no longer attached to your handheld. Your data is being recorded in here. You can leave it and go away, and it will continue to read data. So it's a very similar idea to our continuous temperature probes that we did, where we programmed it to take a reading every hour throughout the day. So once that continuous temperature probe was deployed into the stream, it continued to take that temperature reading every hour on the hour for as long as you leave it in the field. Oftentimes 3, 4, 5 months at a time. Data zones can be deployed in that exact same way, only instead of just taking the temperature, now you can get your dissolved oxygen, your conductivity, your pH, and your temperature all being recorded at whatever time interval you want. So like continuous temperature probe, it's not uncommon to take it every hour, every half hour, something like that. You can take, if you have different probes in here, you can look for algae, chlorophyll A readings, and so you kind of get a feel as you go throughout the summer how your algae is building up, and then you can relate that to the other readings that are on here, your pH, your DO, and your temperature, to decide if maybe those are correlated, so that as your temperatures and DOs and stuff change, that's what's promoting the growth of the algae. So these are all real and important in really analyzing, kind of doing a deeper understanding than you would normally get with your multi-parameter probe, where you're only taking a reading, once every week or two. Even if you just came out and did it every day, this is still going to tell you way more than that would, because you just have so much more data to be able to correlate. For calibrating, these are, especially the older ones, were really complex. It's difficult actually to, like when you're doing your pH probe, we had to put the pH solution just over the pH probe and then take the reading on that while trying to balance that, or have this in some kind of a stand to hold it up, and it was just kind of a hassle. They've improved up, starting basically with these XO models, where you can just put your solutions now in here. You just put this in, and then you hook it up to a computer through some cables, and it'll actually go through and do kind of does the calibrations more or less for you. You still have to monkey around with changing solutions out for the different kinds of things, but much easier than it used to be, and a little more just a little more automated for you. When you get on site, after you've calibrated it in the lab, it's quite oftentimes the case where you will want to give a on-site calibration audit, and the way you do that is you have your multi-parameter probe and this, and you put them both in the same bucket, allow them to stabilize, and then take readings of all the matching parameters. So the DO reading on your multi-parameter probe should match your DO reading on your data zone, or at least come within, I think it's 5% is where the variance that they allow. The same thing with your temperature, DOs, pH, conductivity, kind of do them all that way. You then usually attach this to a line that is metered, so that you tie a rope on here. The probes are down here, so you kind of take that into account when you're trying to find your depth, which is another thing that this does automatically, is tell you how deep the probe is. That's really handy. You don't have to kind of keep track of it so manually as you would for the multi-parameter probe if you were trying to do any kind of depth within your odd strain range or that that probe. So you lower it when you're taking a a depth profile. What you do is you start at the surface, and the idea of a depth profile is to go down 1 meter and take a reading, and then go down another meter and take a reading, another meter and take a reading, and you do this all the way until you get to the bottom of the lake. What this does is it'll show you things like thermoclines and what your DO levels are above and below the thermocline. So a thermocline is a layer of water that's usually in the middle of a water body, or not necessarily in the middle, but at some depth in a water body. Very kind of stable structure. It's stable enough that sonar actually bounces off of it. In the military, submarines will actually hide underneath thermoclines because they're able to kind of blend in more with the background as sonar kind of bounces off of the thermocline layer. Above the thermocline is usually warm water in the summertime. It's like a lid on the bottom, so the bottom and the top water do not mix. But by putting that lid on, oftentimes the bottom water will become deoxygenated. There's bacteria and stuff that are on the bottom of the lake in the benthic area, on the bottom sediments, and those are alive, and they will consume the material that's down there. Well, they're breathing or using oxygen while doing that, and eventually they use up the oxygen that's within the water around them. And because of the thermocline is such a tight lid, the oxygen that's up on the surface won't mix down like it normally would. So the bottom of the area can become anoxic, or without oxygen. This is very important in lake science and in limnology, where the bottom layer, when it becomes anoxic, allows chemical reactions, especially with phosphorus, to be released from the bottom layer. The phosphorus being released from the bottom, phosphorus is basically a nutrient, a type of fertilizer, and that reaction will fertilize your water and cause algae growth. So a lot of the problems that we're seeing now with lakes having harmful algae blooms, you see lake is being closed, or advisories being put on by the state, including 10 Mile Lake, where the algae is very thick, and at least part of that is thought to be, especially in deep lakes, be caused by that thermocline forming and the area under that thermocline becoming anoxic, which triggers those nutrient releases from the bottom and creates this whole cycle of things that happen. So one of the real helpful things about the data zone is it can really show you how your lake is stratified, where the oxygen levels are good and where they're kind of in that middle zone. In the thermocline, you'll see you'll have high oxygen, high oxygen, high oxygen, and when you hit the thermocline, you'll just see on a graph it'll just go over and suddenly go from 8 milligrams per liter to 5, 3, and then 0 within maybe 5 feet or something. So the whole top 25 feet will be well oxygenated. When you hit that thermocline, it just immediately starts to go down. And then below the thermocline, oftentimes, is literally 0. There just won't be any oxygen at all. Kind of remarkable that it's just totally consumed and just will not mix with that upper layer due to that kind of stability of that thermocline. And the data zone is really what shows you that. When you're doing those, they call depth profiles, that's where you're lowering it by that 1 meter and taking a reading. You lower it a meter, you let it sit for 3 to 5 minutes, and you take the reading, you lower it down. You don't really take the reading because actually all the data is being held within the data zone itself. So this is all something you'll find later. So then you just go down another meter, again, go down another meter, just keep going until you get to the bottom. You can also use static deployments where you just hang the probe either in a creek. You could put it in a creek. tricky part with these is they're kind of big, so you have to figure out a way to hold it in place and keep it there. But that really shows you the diel cycle of the DO and the temperature. So the continuous temperature probe is telling you the exact same thing for the temperature. The data, they call it the diel, D-I-E-L, diel cycle of the temperature throughout the day. So as it goes down into night and then back into morning, it'll go up and down. And the data zone will show you the same thing with a dissolved oxygen, pH, and your conductivity, along with your temperature. So it's really great to be able to see how everything is cycling. One of the things that shows you is the fact that the plants give out oxygen in the daytime when they're photosynthesizing, but at nighttime they absorb oxygen. So when you have a data zone, you'll oftentimes find not only the temperature varying dramatically, but you can go, if you're in a small stream and it's just choked with, especially like invasive weeds, like I see a lot of parrot feather in 10 Mile Creek. Had instances of this where I'll go up in the morning or look at the data from the morning, and it will be just no oxygen at all, even within the 1 foot or whatever that I'm measuring in that creek, 1 foot depth. And yet you go back in the evening or in the late afternoon, and you'll have 120% oxygen levels, because there's so many plants in there. They're just producing so much oxygen that water is almost bubbling practically with oxygen. So there's a lot of information that these can tell you. They use them in the ocean also, kind of the same basic things, maybe different probes, but there's a lot of information that can come from a data zone. Let's see. You are able to kind of use it just as a static, as I said. If you, for instance, want to find out whether the area underneath a thermocline has zero oxygen and just stays zero oxygen throughout the whole month, then you can deploy one of these down and just leave it. Instead of lowering it 1 meter every time, you can just take it out and deploy it. The tricky part of these is they're very expensive piece of equipment, probably $10,000 or something like that. So your security really has to be well thought out on that. So what usually happens is you'll have an anchor that'll attach to the data zone along with a float, and quite oftentimes we want the probe to be about a half a meter off the bottom. So we'll just have the anchor down here with a half a meter with the length of cord open, so that it'll be stationed a half a meter, float a half a meter up. We'll put a float up at the top here. And then the tricky part is if you're in let's say a 70-foot depth lake like Eel Lake, you can deploy this, but then how do you get it back again? Well, you could attach, you have your little float here that's keeping this 1 meter up off the bottom. You could also attach another rope and have it go up to the surface and have a float up there. The problem is that unless you're able to monitor that, somebody can come along and see the float, be curious about what it is. They may think it's a fish trap or something, and they'll just pull it up. Well, now somebody has your $10,000 piece of equipment in their hands. So what we did in Eel Lake to kind of solve that problem was to create a loop underneath the water. So we tied one end here. We had a second anchor that was about, I think we used about 100 feet of line, and the other end of the line had an anchor on it, and we put 2 floats in the middle of the line, so that this was anchored on one end. You had the line arcing underneath the water to another anchor a distance away, and 2 floats in the middle of that line, so that the data zone would be down here. Your floats would be floating up here in the water, probably 20 feet or something off of the bottom. We then, that's the way we would, when we deployed it, we'd sank this first. We would then take the second anchor, drive the boat away, let it go. So there's this big arc between the two because the floats are in the middle. We would then take, when we were done and wanted to retrieve the data zone, we would take a grappling hook off of the boat, we would throw it off the back of the boat and troll, trying to get the grappling hook to catch that loop of the line that's between the data zone and that second anchor. I tell you, it's a little breathtaking at times when you don't catch the line right away. You know your $10,000 piece of equipment sitting on the bottom and you've got to get it back, and so it's a little nerve-wracking, but to date we haven't lost one, knock on wood. We found that the usual problem when we're having trouble grappling is the grapple hook itself is not weighted enough, and as we're moving forward to the boat, the grappling hook is rising up and misses the loop of the line. It'll go over the top of it and miss it. So, and of course, when you deploy this, you're very, very specific about where you deploy. You use a lot of landmarks. You know, it's in between these three trees. You get a good GPS reading. You really know exactly where it is. Because if worse comes to worse, you could, if you know close enough where it is, you could actually go scuba diving for it if you really needed to. I think that's it for the data zone. Really important piece of equipment, has a lot of good uses, and that continuous data, just like the continuous temperature probe, continuous data where you can get data every hour or every day or every whatever interval that you think is necessary, can really be an amazing set of data. It really shows you what's going on, and with all the different data, with your DO, your pH, your conductivity, and your temperature, all being recorded at the exact same time and all throughout, throughout the summer or throughout the year or whatever deployment time you have. It's just really valuable data. So these are really important to be able to use, and hopefully on one of your jobs that you get in the future, you'll have a chance to use one. All right, until next time, be safe.